Every year, gardeners spend billions on synthetic products designed to feed plants directly, bypassing the very biology that makes soil productive. We pour soluble nitrogen that washes away with the rain, and liquid fertilizers that offer a fleeting growth spurt only to devastate microbial life for months. But what if one of the cheapest, most common kitchen staples, ordinary rice, could permanently multiply your soil's earthworm population, ignite explosive microbial growth, and boost crop yields by up to 25%, all for just a few cents? The agrochemical industry, a multi-billion-dollar enterprise, thrives on ensuring you never connect a 50-cent bag of rice to the vibrant, living system it awakens beneath your feet. The truth is about to be unearthed. Consider this. A single square meter of healthy garden soil can host over 300 earthworms. Each day, these industrious creatures process their own body weight in organic matter, transforming dead plant material into castings so incredibly nutrient-dense that they contain 5 times more nitrogen, 7 times more phosphorus, and 11 times more potassium than the surrounding soil. Earthworms aren't just beneficial inhabitants. They are the very engine of a productive garden. This isn't anecdotal. It's scientifically proven. A landmark 2014 meta-analysis, published in Scientific Reports and considered one of the most cited soil ecology papers of the last decade, examined 58 controlled studies spanning over a century of field research. The conclusion was undeniable. The presence of earthworms in agricultural soils increases crop yield by an average of 25%, above-ground biomass by 23%, and total plant biomass by 21%. Crucially, these effects were most pronounced when organic residues were present in the soil, precisely the conditions that rice helps create. A more recent 2023 study in Nature Communications took this further, estimating that earthworms contribute to approximately 5% of total global grain production. They are not a mere garden bonus. They are a fundamental food security infrastructure that most gardeners have simply never been taught to nourish. So, what exactly do earthworms eat? It's not soil, not roots, and certainly not synthetic fertilizer. Earthworms consume microbes. The bacteria and fungi that colonize decomposing organic matter are the primary food source for every earthworm species in your garden. This means the more microbial activity in your soil, the more earthworms will arrive, reproduce, and thrive. The real question isn't how to buy worms. It's how to feed the microscopic organisms that, in turn, feed the worms. And rice, in 4 distinct forms, provides that exact solution. This crucial knowledge was never truly lost. It was simply waiting in your kitchen. Here are the 4 powerful rice tricks the industry never wanted you to discover. Trick 1. Cooked rice, the fast-acting worm magnet. A small handful of plain cooked rice, either placed on the soil surface or buried about 2-5 centimeters deep, achieves something no synthetic product can replicate. Within 24 to 48 hours, the starches in the rice begin to break down. Bacteria are the first to arrive, rapidly colonizing the grain surfaces and consuming the simple sugars released during decomposition. Fungi follow within days, threading their hyphae through the softening grains and extending their intricate networks into the surrounding soil. This concentrated microbial bloom is precisely what earthworms detect and are drawn to. Crucially, earthworms don't eat the rice itself. They consume the microbial film that the rice generates. This distinction is vital because it explains why a few tablespoons of cooked rice can attract more worms than a full application of synthetic fertilizer. Fertilizer feeds plants. Rice feeds the organisms that earthworms consume. The signal is biological, not chemical. This mechanism is confirmed by multiple university extension programs, including Cornell Cooperative Extension, the University of Connecticut Soil Testing Laboratory, Ohio State University, Utah State University, and Purdue University Extension. Their vermicomposting guides consistently list plain cooked rice and other grains as excellent food for composting worms. The consensus is clear. Cooked rice, free of oil, salt, or seasoning, is one of the fastest decomposing organic inputs you can add to soil or a worm system, jump-starting microbial activity within hours. The application is simple. Scatter 2 to 3 tablespoons, 30 to 45 milliliters, of plain cooked rice per 1 square meter across your garden bed. Lightly press it into the surface and cover with a thin layer of mulch. The mulch helps retain moisture, preventing the rice from drying out before microbes can colonize it. Repeat this process once every 2 to 3 weeks throughout the growing season. Within a month, you'll observe a visibly higher earthworm casting density in treated beds compared to untreated areas. The cost is virtually zero, and the biological return compounds with every application. A word of caution, backed by science. Applying too much starchy material at once can temporarily create anaerobic conditions as microbial oxygen consumption spikes. Small, frequent applications consistently outperform large, single dumps. The key is to feed the system steadily, not all at once. Trick 2. Crushed uncooked rice, the slow-release underground feeder. While cooked rice offers a rapid boost, crushed uncooked rice operates on a different principle. Its raw starch granules break down more slowly, providing a sustained food source for microbial populations over weeks rather than days. This creates a longer, steadier biological signal that keeps earthworms actively engaged in the treated zone throughout an entire growing period instead of a brief, fading burst. This mechanism is directly supported by vermicomposting research. A 2016 study published in the International Journal of Environmental Health by Porzamani and colleagues investigated rice bran and broken rice residues as feedstock for earthworm systems. The findings revealed that rice bran, when combined with food waste, produced high-quality vermicompost with rapid stabilization and significant nutrient enrichment. The earthworms efficiently processed the rice-based substrate, and the resulting castings exhibited elevated nitrogen, phosphorus, and potassium levels compared to control groups without rice. The overarching principle, consistently confirmed across numerous papers in soil biology and biochemistry and applied soil ecology, is that labile carbon sources, such as starches, sugars, and simple carbohydrates, are the single most effective drivers of earthworm reproduction and biomass gain when incorporated into compost or soil. Raw rice stands out as one of the cheapest and most shelf-stable carbon sources available to any gardener. To prepare it, simply crush dry rice lightly with a rolling pin or pulse it briefly in a blender. The goal isn't to create flour, but to crack open the grains, exposing their starchy interior to soil moisture and microbial access. Scatter the crushed rice at 1 to 2 tablespoons, 15 to 30 milliliters per 1 square meter, and lightly work it into the top 5 centimeters of soil. Cover with mulch. The crushed grains will absorb soil moisture, swell, and gradually begin releasing starch over the subsequent 2 to 4 weeks. Microbial populations will steadily build around each grain fragment, and earthworms will follow. For maximum impact, consider alternating cooked rice applications every 2 weeks with crushed raw rice applications monthly. The cooked rice provides that initial, rapid microbial spike, while the crushed raw rice maintains a sustained baseline. Together, they establish a continuous feeding cycle that keeps earthworm populations elevated throughout the entire growing season. Trick 3. Fermented rice water, the liquid microbial accelerator. This particular method boasts the strongest direct scientific backing, connecting rice to soil biology through published, peer-reviewed field trials, moving beyond mere extension guidelines. When you rinse uncooked rice before cooking, that cloudy water isn't just waste. It's rich in dissolved starches, amino acids, B vitamins, phosphorus, potassium, and a range of micronutrients leached from the grain surface. When this water is allowed to ferment at room temperature for 24 to 48 hours, it transforms into a concentrated liquid microbial inoculant, ready for direct application to your garden soil. A groundbreaking 2023 study by Nabayi and colleagues, published in Helion and indexed through PMC, rigorously tested fermented washed rice water across 3 consecutive field planting cycles. The results were truly remarkable. Fermented rice water significantly boosted beneficial soil bacterial populations, including vital nitrogen-fixing bacteria and organisms capable of solubilizing phosphorus and potassium. This led to measurable improvements in plant growth, increased nutrient uptake, and a rise in soil bacterial diversity across every treated plot compared to untreated controls. A 2021 study by the same research group, published in the journal Sustainability, meticulously documented the fermentation process itself. They found that allowing washed rice water to sit at room temperature for 2 to 3 days dramatically increases the concentrations of beneficial bacteria, while also elevating nutrient levels within the liquid. The fermented product becomes richer in available nitrogen, phosphorus, and potassium than the raw rinse water, delivering these nutrients alongside a vibrant, living microbial population rather than in an isolated chemical form. The application is straightforward. Rinse 240 milliliters of uncooked rice in 480 milliliters of water. Collect the cloudy rinse water in a jar or bottle. Cover it loosely to allow gas exchange, and leave it at room temperature for 2 to 3 days. You'll know it's ready when the liquid develops a slightly sour smell, indicating active fermentation. Dilute the fermented rice water 1-to-1 with fresh water and apply it directly to the soil around your plants once per week. Remember, you're not feeding the plant directly. You're feeding the microbial community in the rhizosphere, the very community that earthworms consume, and that makes nutrients available to roots. Fermented rice water is a powerful, living soil drench that costs nothing. Utilized as a kitchen byproduct, most people simply pour down the drain and delivers measurable, scientifically confirmed results across multiple peer-reviewed field trials. Trick 4. Rice in the worm bin and compost pile, the population multiplier. While the first 3 tricks focus on the garden bed itself, this 4th method targets the systems that supply your garden, your worm bin and your compost pile, significantly amplifying the output of both. In a controlled bin environment, earthworms respond to rice-based inputs with measurable increases in reproduction rates, biomass, and casting production. Virtually every university extension vermicomposting guide that lists approved feedstocks includes cooked rice, cooked grains, and rice residues as top-tier food sources for composting worms. The underlying mechanism is identical to what happens in the garden bed. Rice generates a dense microbial bloom that worms voraciously consume. A 2018 study by Eliamin and colleagues, published in the International Journal of Environmental Research and Public Health, investigated the interaction between earthworms, rice straw, and plants in controlled soil systems. Their research showed that rice residue significantly increased earthworm body weight and biomass while simultaneously reducing mortality. The earthworms thrived on the microbial communities colonizing the rice material, converting it into castings that measurably improved soil structure and nutrient availability. Further supporting this, a 2020 study published in PeerJ documented that earthworms completely consumed rice straw residues within 4 weeks in mesocosm experiments, whereas identical residues without earthworms remained largely intact even after 18 weeks. The earthworms effectively converted the rice carbon into organic carbon, increasing the total carbon content of the soil while simultaneously boosting enzyme activity across multiple nutrient cycling pathways. The practical application has 2 distinct layers. In your worm bin, add small amounts of cooked rice, 2 to 3 tablespoons, 30 to 45 milliliters, per feeding mixed in with your regular kitchen scraps and bedding. The rice accelerates microbial colonization of the entire bin contents, which, in turn, increases worm feeding speed and casting production. For your compost pile, scatter a thin layer of crushed raw rice or leftover cooked rice between your green and brown layers. The starch content accelerates the decomposition of the surrounding material by feeding the bacterial populations responsible for breaking down cellulose and lignin. The rich output of both these systems' worm castings and finished compost then returns to your garden beds, where it continues to nourish the earthworm populations you've been building with tricks 1 through 3. This creates a powerful, self-sustaining cycle. Rice feeds microbes, microbes feed worms, worms produce castings, castings build soil, and healthy soil grows abundant food. The cost of initiating this cycle is merely a handful of rice, but this fundamental knowledge was never truly lost. Rice, as a powerful driver of soil biology, never disappeared into agricultural industry archives or product development pipelines. While the synthetic input system was consolidating into a multi-hundred-billion-dollar machine, traditional farming communities across Asia continue to use rice water, rice straw, and rice residues as primary soil amendments for thousands of years without interruption. Japanese natural farming traditions, preserved through the 20th century by practitioners like Masanobu Fukuoka, incorporated fermented rice preparations as standard soil treatments, decades before Western soil science published its first peer-reviewed paper on the mechanism. Korean natural farming systems codified rice-based microbial inoculants as a core practice generations ago. Rice paddy farmers across Southeast Asia, for centuries, consistently returned rice straw and residues to their fields, maintaining robust earthworm populations and unparalleled soil fertility without a single synthetic input. Western science eventually caught up. Van Groningen's 2014 meta-analysis in Scientific Reports quantified precisely what traditional farmers already understood: that earthworms increase yields by 25% when organic residues are present. Nabayi's 2021 and 2023 field studies confirmed what Korean and Japanese farmers had practiced for generations: that fermented rice water measurably improves soil biology and plant growth. And the 2018 and 2020 studies on rice residues and earthworm interactions documented what every rice paddy farmer in history could have told you: that worms absolutely thrive on rice. Today, this vital knowledge is rapidly accelerating in home gardens, not because the industry permitted it, but because gardeners, witnessing their fertilizer bills climb and their soil biology collapse, began asking why a 50-cent bag of rice could achieve what a $50 jug of liquid fertilizer never could. The silence surrounding rice as a soil amendment is finally breaking. You, too, can cultivate what they overlooked. Start with what you already have. If you cook rice, save the rinse water tonight and ferment it for 3 days. If you have leftover cooked rice, scatter it on your garden bed tomorrow morning and cover it with mulch. If you manage a worm bin, add a small handful of cooked rice at your next feeding and observe the population response within 2 weeks. If your garden soil is biologically dead, combine all 4 tricks across a single season and watch the earthworm population rebuild from nothing. The total investment for all 4 rice tricks, applied across a full growing season, runs under $5. That's less than the price of a single bottle of liquid fertilizer at any garden center. And these tricks don't stop working when a bottle is empty. Each application feeds the microbial community that feeds the earthworms, which in turn produce the castings that build the soil, which ultimately grows your food. This cycle is self-reinforcing. The cost approaches zero. The biological benefits compound year after year. The agrochemical industry profits from the assumption that soil fertility must be purchased in bags and bottles every single season. These 4 rice tricks begin with the opposite truth. The cheapest staple in your kitchen can permanently activate the most powerful biological workforce in your garden, and those worms will do the rest for free. The knowledge was never lost. It was waiting in the rice pot, in the rinse water, in the compost pile, in the hands of farmers who never needed a synthetic product to build truly living soil.